All right, welcome everybody. Ms. Lupinski here again. We're going to spend a second day talking about Chapter 3 applications of quadratics, which of course means word problems. To refresh your memory, on the first day, we spent some time getting familiar with the vertical motion model, talking about where the different values came from, how do we know if they should be positive or negative or zero. We're going to see some similar types of problems today, but the major difference is that we're going to try to solve them using some kind of graphing utility. So if you have either a TI-83 or a TI-84 graphing calculator, you should definitely have that out and handy for today's lesson. If you don't have one of those calculators, then you're going to want to use the Desmos website, which to remind you is www.desmos.com. Now, a couple things just to preface the lesson. First of all, I ask for your patience since I am going to be going back and forth between this screen, the Desmos screen, the graphing calculator screen. So just be patient and try to write down as much as you possibly can. Secondly, the truth is that the commands for the graphing calculator can actually seem harder than the Desmos ones. So it is your choice which one you're going to use, not only for the lesson today, but for any problems this year. But keep in mind that in the future, next year, if things do eventually go back to normal, it's possible that you'll only have access to your graphing calculator. So if you do have one, you might strongly want to consider starting to practice with it so that you can use it in the future. So take a look here at number 1. A ball is thrown straight up in the air from the top of a 128-foot tall building with an initial speed of 20 feet per second. The height of the ball as a function of time is given by the equation y equals negative 16x squared plus 20x plus 128. And again, you're going to use a graphing calculator or Desmos to help you answer the following. So first, let me just point a couple of things out about this equation. So notice that this is y equals as opposed to being h of t equals. Doesn't matter what the variables are. They all kind of mean the same thing as defined in the problem. So notice first, you have the negative 16x squared. Remember, of course, that negative 16 takes into account gravity as long as your problem is in feet, which it is. Then notice that it said that it was a 128-foot tall building. So that is the starting height of the ball, which of course goes in the back. Then, because of the fact that the ball was thrown up at an initial speed of 20 feet per second, remember throwing something up is a positive initial velocity, so that's why you have that positive 20x in the middle. And so far, all of that is review from the first day. So if you have a question, be sure to ask your teacher straight away before we get started. So I have for you a picture here. Here is the building. Here is where the ball is being launched from. Obviously, it goes up to its highest point in the air, and then eventually what goes up must come down, and it must land at some point in time. So instead of finding all these values just algebraically, we want to use some kind of graphing utility. So for those of you who do have a graphing calculator, go ahead and turn them on. And the first thing we're going to do is we're going to type that equation into our graphing calculators. So let me pull that up. Here is the screen that you should see when you turn your calculator on. You're going to go ahead and click top left, which is the y equals. If there is anything in your screen, you should clear it out. If for some reason any of these plots are highlighted, you should unhighlight them until you have a perfectly blank screen, exactly like I have here. You're going to go ahead and type in the equation exactly as it appears on the worksheet. So starting with a negative, and make sure you choose the negative, not the minus. And then 16. Whenever you choose a variable, you're going to choose this button here next to the green alpha key. So you're going to choose x. You're going to choose the squared plus 20x plus 128. So we have used the graphing calculator, and we've shown you a couple of these commands just briefly over the past couple of weeks. It's possible that some of you have been playing around with it more than others, but if you haven't, then you really should be able to follow these steps one at a time. So as soon as you confirm that what you have typed in is exactly the same as what's on your paper, you can try to pull up the graph by pressing the top right-hand key, which is the graph button. As you can see here, I see something on my screen in blue, but it doesn't quite look like a quadratic. It's supposed to look just like the picture on your worksheet. The reason why is because of something called the window. And again, you might want to write down these buzzwords that I'm saying so that when you go back later, you'll be able to kind of duplicate the process. So the window button is here in the top row next to the y equals. And if you press the window, this tells you exactly what values are being shown on your screen. X min and X max, that means from what X to what X, and Y min to Y max means from what Y to what Y. Notice that they are both negative 10 to 10. Now, if you go back to the problem and you read, they are telling you that one of the variables is the time. So no matter what you are throwing into the air, it is never in the air for very long. So in terms of your X values, -10 to 10 is actually fine. While you're not going to have a negative answer, certainly, sometimes it helps to just kind of see the negative on the graph as a point of reference. And the idea that something could be in the air for 10 seconds, really that seems like one of the higher values, so that's perfectly acceptable. Then consider the y value. So again, while you're not going to have a negative height, it helps to have a little bit of negative there just as a point of reference. And then consider how high could this ball potentially go. You are already launching it off a building that is 128 feet high. So we know that that's your starting point. It has to go higher. How high do you think that ball can possibly go? 1,000 feet? Definitely not. 2,000 feet? Definitely not. If you're starting at 128 feet, let's assume you're the strongest person ever and you launch that ball with all the force you've got behind you. Let's say maybe the highest it could go is 200 feet. That would only be a difference of 200 minus 128. So it's not that you're throwing it 200 feet in the air. That would just be the difference. But again, you're going to choose some values here that seem reasonable. And then as soon as you think you might have a good idea, you're going to press the graph button again, and you'll be able to tell relatively quickly whether or not it makes sense. So again, the graph is still not perfect. You could kind of decrease the y values or decrease the X values if you wanted the graph to fit perfectly on your screen. But this is really pretty good. And again, why does it look pretty good? Well, go back to the worksheet here. So taking a look at what's going on here, notice that normally the graph would continue on to the ground here, but that part of the graph doesn't actually make sense. As far as we're concerned, that would be negative time since we are starting our problem here when the ball is released. So if you look at your graphing calculator, the negative part of the graph doesn't really make sense in the context of the problem, but we still see it because your graphing calculator shows you everything and you have to be a little bit smarter than it. So the first question on the worksheet is from what height is the ball thrown from and what do we call this value? So that should be something that you should be able to answer without doing anything. That is, of course, the starting point, which is the y-intercept, which is 128 feet. If you want to find that on the graph, here's what you do. You're going to press the second key, and then you're going to press the trace button. So the trace button is in the top row next to the graph. This brings up what's called the calculate menu, and this is all the good stuff. So this is where everything you're going to need for the next couple of weeks comes from. You are trying to calculate a simple value, so you're going to choose the first choice, which is value. The calculator is going to say, well, what do you want the x to be? So hopefully you recall that a y-intercept means that x is 0. Then you're going to hit enter, and it is going to not only list the value for you, so you see x equals 0, y equals 128, but you also see the flashing cursor exactly on the graph where it should be. So let's go back to our worksheet and make sure we write that. So from what height is the ball thrown from, and what do we call this value? So the point that we're using is 0, 128. 128 feet is the answer. And what do we call this? This is the y-intercept. And again, as a reminder, what did we do on the graphing calculator? We chose the value button. We made x equals 0. And the way that we did that is hitting second, trace. And again, that's going to kind of be the options most of the time. That's where all the good stuff lives. So then, how high is the ball after exactly 2 seconds? So please be advised that you could just go up to this equation. Everywhere there's an x, plug in a 2, and I promise you would get the answer. But again, the whole point of this is to show you an alternate method. Notice that not only do we want to know how high is it after 2 seconds, we also want to know how high is it after 1.25 seconds. So essentially, we're looking for those two ordered pairs. We're looking for 2 comma something. We're looking for 1.25 comma something. And in both of those cases, we are looking again for values. So we're going to duplicate the same process we did for number 1. So back to the graphing calculator. We're going to again press second, then trace. We want to calculate a value. After 2 seconds, plug in 2 for x, hit enter, 104 feet. Write that down on your paper. Then do it again. Second trace, value, 1.25 seconds, 128 feet. So hopefully you've written those down, but if not, let's just go ahead and double check. So 2, 104, that's 104 feet. 1.25, 128, that would be 128 feet. So just highlight here to make sure we've got the answer. So 128 for the first one, 104 for the second one, 128 for the third one. You'll notice here the answer to number 1 and number 3 is the same. Well, how is that possible? How is it possible that the ball can be 128 feet at both locations? Well, that of course means that it's once on the way up and once on the way down. So perfectly acceptable that you get 2 different X's for the same Y. Notice here in number 4, they are asking you for the maximum height that the ball reaches. So hopefully you remember that the maximum height is up here. Where do you find this value? Hopefully you remember that the magic word is the vertex. So we're going to go ahead and find that. And again, you could do negative b over 2a and then plug that value back in for all the x's. I promise it would work. But again, the whole point is to show you another option. So going back to the graphing calculator here, you're going to stick with that same menu, second trace. What is it that you're looking for? Well, you're looking for the maximum value, so that is handily called the maximum. So you're going to go ahead and choose it, and then it's going to ask you for something called the left bound. So scroll your cursor to where it looks like the highest point is, and then the left bound means you have to go somewhere to the left. When you're comfortable with where you are, hit enter, and it's going to draw you a little dotted line. Then go back to where you think the maximum is and choose a value to the right and choose enter. It doesn't really matter how close or how far away you are. You just have to clearly be to the left of the answer and then clearly be to the right of the answer. It's going to ask you to guess, which you can do if you're fancy. I probably just skip that step. And if you hit enter one more time, it's going to give you the exact coordinate of that point. So I would go ahead and round to 2 decimal places as it asks you to do. So that would be 0.63, 134.25. So write that down. And again, we'll go back to the other screen. So we're going to copy that ordered pair. So 0.63, 134.25. Make sure that's a point. And then just to make sure we answer, what is the maximum height? So the maximum height would be 134.25 feet. Remember, the 0.63 means that it takes 0.63 seconds in order for the ball to reach its maximum height, which is 134.25 feet. How long is the ball in the air? So how long is the ball in the air? Well, we will know that the ball is no longer in the air once it reaches the ground. So once it reaches the ground, that is this value right here. Where are we going to find that graphically? Well, again, all the good stuff is if you press second trace. You're looking for hopefully the x-intercept. Hopefully you remember that another word for x-intercept is the 0, and that's what the graphing calculator calls it. So you're going to choose the 0 button, and it again asks you for the left bound. So remember, there's a positive answer and a negative answer. We're clearly going to choose the positive answer since that's the only one that makes sense. So you're going to get closer and closer and closer to where it's crossing the x-axis, and you have to make sure you're on the left side of it, which in this case means above. Hit enter. Then scroll to the right of where the x-intercept is, which in this case means below. Notice I can't really see it anymore, but I can see based on the ticker there where it is. So I'm going to hit enter. Guess if you're fancy, otherwise hit it one more time, and it's going to show you exactly where the x-intercept is. So you should write that down as 3.52, 0. Just as a quick note here, it's possible on your calculator that instead of saying y equals 0, it says 1e, -10, -11. That is scientific notation, which would be 0.00000001, which is essentially 0. So just so you know, depending on how your calculator is set up, if it shows you that weird e thing, that's just scientific notation, which again is the same thing as 0. So we're going to go ahead and go back and fill that in on our paper here. So 3.52, 0 was the point. And then to answer it, it's 3.52 seconds. And what do we call this value? This is either called the x-intercept or the 0 if you're using the graphing calculator. Then a bird is flying nearby at a height of 100 feet. If the bird flies into the ball's path when it has been in the air for 2.5 seconds, will it get hit? Give specific values to support your answer. So there's a couple of different ways that you could solve this. If you go back to the graphing calculator, and if you go back to the y equals, you're actually allowed to plug in as many equations as you want at the same time. So you're going to actually down arrow to y2, and you're going to type in 100, that represents the flight of the bird. If you go ahead now and press graph again, they're going to show you the path of the bird. So because the bird flies into the path of the ball, we have to see whether or not that poor bird is going to get hit. And in order to answer it, we have to know exactly what is happening to the ball when it's been in the air for 2.5 seconds. So we are being asked about a specific value of time. So we're going to go ahead and use that value option. So remember, second trace. Again, that's where all the good stuff is. We're going to choose a specific value, and in this case, 2.5 seconds. So when you hit enter, look at that. The ball is only at 78 feet, which means the bird at that time is above the ball, which means it's not going to get hit. Phew. So let's go ahead and write that up. So a bird is flying, give specific values. So will it get hit? So the value that we chose, is the point 2.5, comma, and the path of the ball is at 78 feet. So will the bird get hit? No. The ball already dropped below 100. So the bird is safe. Phew. Okay, last but not least, domain and range. So I don't have to do any additional work to answer this question. I just have to use common sense. Remember that when it's a word problem, no infinities are allowed. That doesn't make sense. Nothing is ever in the air for an infinite amount of time. So going back to the picture here, the domain is going to be the starting value of x to the ending value of x. And that's talking about time values. So the problem always begins at time equals 0. The ending value of time is how long it takes the ball to land, which we already found was 3.52 seconds. You're going to use a bracket on each of those ends because both of those time values are included. Negative values don't make sense, and you can't go above 3.52 because then the ball would have already landed. Give the range of the ball in interval notation. So the range of the ball, well, the lowest that the ball is ever going to go is it hits the ground, 0. The highest that the ball is ever going to go is its maximum height, which again, we already found. So no infinities allowed. The minimum height of the ball is 0, and the maximum we already found was 134.25 feet. So definitely a lot going on here. Again, it might seem like it takes more time to use a graphing utility than it does to just plug stuff in. And sometimes that can be true, but you'd be surprised how good you get at this the more you do of them. Plus, there's a lot of times that the values wind up being messy, which means that solving them algebraically can be a bit of a pain. Just to show you on Desmos what this would look like. So again, this is the website, desmos.com. You would then open up the calculator and you would go ahead and again type in the equation. So y equals -16. You would then have to bring up the little keyboard here. You're going to do x squared. Oh, I think I forgot my negative. Okay, so -16x squared. Notice that the graph is changing as I type, plus 20x plus 128. Again, we have the same issue we had on the graphing calculator. It kind of looks like there's something there, but it doesn't really look like a quadratic. So you again have to change the window. The way you change the window in Desmos is by pressing a little wrench and then looking where it says x-axis and y-axis. So for the x-axis, -10 to 10, that's for the time values. For the y-axis, it only goes up to 8.115 feet, which is clearly not enough. Remember that we had said, let's use 200, assuming that that's how high it might go. That then gives us a much better picture. And again, if you click anywhere using the mouse, you can kind of drag it a little bit. If you wanted to find the values that we did for this problem, you basically just have to click around. So if you click near the top, it will automatically show you what the highest value is, which is, of course, the vertex. It will then also bring up the y-intercept for you. It will bring up both of the x-intercepts, which, of course, you would only choose the positive one. And then for any value of x that you wanted, if you click and drag, you can choose to go to any value of x that you want, 1.5, again, any positive or any negative. So again, theoretically, this is faster, so feel free to use this. The only thing is that in the future, you might not have access to Desmos, so you might want to consider using the graphing calculator for at least a couple of the problems. This is the only Desmos example I'm going to show you, but remember, if you wanted to do any other problem using this, go to the website, type in the equation, and then if you kind of click around, it automatically shows you the important values, and then you can drag to find any other value. Let's go to the next question here. So Kevin and Brady are trying out for the quarterback on the football team. Whoever can throw the ball farther down the field will be added to the starting roster. Kevin's best throw is given by this equation here in yellow, and Brady's best throw is given by this equation here in blue. Who will win the position? Assume that x is the horizontal distance that you can throw it down the field in yards, and y is the vertical height in feet. Something you want to notice here is that there is no time in this problem. So if there is no time, that means that the values are going to be larger. So what I want to do here is I want to first solve for Kevin. So Kevin's equation is negative 0.04 x squared plus 3x plus 4. He's starting at 4 feet. He's throwing it up, and it's eventually going to land down. Then you have Brady. He's actually throwing it from the same starting value of 4, and then he's going to throw it, and it's going to come down. The question is, of these x-intercepts, whose one is going to be farther down the field? And again, remember, another word for x-intercept, according to the graphing calculator, is the 0. So I'm going to go ahead and go back to my graphing calculator. I'm going to go to the y equals, and I'm going to clear out both of these equations. So I'm going to press clear. I'm going to press clear for y1. I'm also going to press it for down arrow to y2. Very carefully, make sure, again, you're using the negative, not the subtraction. So 0.04, don't lose any decimal places, x squared plus 3x plus 4. Again, after you type it in, you can try pressing the top right button graph, and you may or may not see it. Unfortunately, in this case, I see something, but it looks nothing like what I want to, which means you have to change, again, the window. So in the window, keep in mind here that there is no time. Left to right, the x's, is the length of the football field. Well, a football field, if you didn't know, is 100 yards. So let's go ahead and assume that maybe one of these guys can throw it all the way down the field. Then in terms of the y value, so the y values is potentially how high one of these guys can throw it. Well, I'm not really sure. 200 seems a little high. Let's give them a little credit and maybe say 100. Even that seems high, but again, a little bit high is fine. A little small is just not. So now when we press graph, there we go. So that is Kevin's throw. We want to know how far down the field he can go. So again, second trace. We're looking for the 0. Get close to the answer on the left side, which means above it. Get close to the answer on the right side, which means below it. Guess if you're fancy. Otherwise, 76.31 yards. Back to my screen here. So 76.31 yards for Kevin. And now I have to figure out how far Brady can throw it. So as I go back to the graphing calculator and I go back to the y equals, I can either delete Kevin and then put in Brady, or I can put Brady in y2 and see them both at the same time, which is what I'm going to do here. So for Brady, I'm going to type in negative 0.03 x squared plus 0.25x plus 4. I just want to make sure that that's right. No, 2.5. See, got to plug it in right or else disaster. Okay. So now the window should work the same. So I go ahead and graph it. So now in red there is Brady. I can clearly see that his kick goes, or his throw goes farther. I just need to find that exact value. So I'm going to go ahead and do second trace. Again, we're looking for the 0. Make sure you're on the red graph. You might have to up arrow or down arrow, so make sure you're on the red graph now. So again, get close to the answer, but on the left, hit enter. Get close to the answer, but on the right, hit enter. Guess if you're fancy, otherwise it'll give you the answer, 84.90. If I go ahead and go back to my screen, so for Brady, 84.90 yards. So who is going to wind up getting the spot on the football field, on the football team? It looks like Brady is going to be the winner. So anytime you're in a problem where you're talking about distance, the 0 will always be how far. If you're ever talking about time, it will be how long. And then our final problem here. So the height the height h in feet above the ground of a t-shirt launched from a t-shirt launcher is given by the following. So notice here we're back to h of t, negative 16t squared plus 64t plus 190, where t is the time in seconds. So what is the height of the shirt after 0.5 seconds? So again, for this problem, you do not have to use a graphing calculator if you do not want to. You could do all the steps without it. The numbers wind up being relatively nice. So that would be up to you. But again, the point of the lesson is to show you something new. So again, option number 1 is you can set t equal to 0.5 and literally just plug it in. I'm going to show you another option. Notice that there are h's, which really are y's, and there are t's, which are really x's. Your calculator only knows x and y, so you have to just convert them. So going back one more time here to my graphing calculator, go back to the y equals. I'm going to clear out both of these. And I'm going to go ahead and type in negative 16x squared plus 64t, or 64x in this case, plus 190. If you try by pressing graph, remember we were in that other window, so we kind of see the graph, but it doesn't quite look the way that we want. So again, go back to the window. We're now back to a problem about time. So if you're back to time, again, maybe the longest anything could ever be in the air is 10 seconds, and even that would be a really long time. In terms of how high it's going to go, you are starting from a height of 190 feet. You have a t-shirt launcher, which is pretty strong. So maybe it goes really, really high. Let's say 300 feet. You'll know right away whether or not that's reasonable if you go ahead and pull it up. And you can see here that the y's and the x's are a little bigger than I need, but a little bigger is okay. It's only an issue if it's too small. So notice that they want to know what's the height of the t-shirt after 0.5 seconds. That is a value. So second trace, choose a value, 0.5 seconds, hit enter. And it turns out that at that time, the t-shirt is 218 feet in the air. So back to here, 218 feet. That's the answer. And again, the way that you would find that on the calculator is by using the value button. Find the time it takes for the shirt to hit the ground. When the shirt hits the ground, that is the x-intercept, which as far as we're concerned, is the 0. If you wanted to solve this by hand, you would have to set h equal to 0 and use the quadratic formula. That would work. But if you're getting better at the graphing calculator, if you go back, press second trace, you're looking for the 0. Get close to the answer, but the left bound, you have to be above. Right bound, you have to be underneath. Yes, if you're fancy. If not, 5.98. And that's 5.98 seconds. Again, things are never in the air very long. I would say 10 seconds maximum. And then finally, find the maximum height of the shirt. So if you're trying to find the maximum height of the shirt, remember that that always occurs at the vertex. You could do negative b over 2a, find the answer, and then plug it in, or go back to your graph, second trace, choose the maximum option. Remember, again, you have to get close to where the maximum is, but you first have to make sure that you're on the left side. Then make sure you're on the right side. Guess if you're fancy. Otherwise, it gives you the following. So 2, 254. Because the question was the maximum height, that would be 254 feet. So the whole point of tonight's homework is for you to try to use some kind of graphing utility, preferably the graphing calculator if you have it. If not, Desmos.com will work. And again, just to pull up Desmos.com one more time, again, you pull up a fresh graphing calculator window, you type whatever equation you need to up here in the y equals, and then if you click around, it will show you all the values that you want. And if you want to do more than one graph at a time, just hit enter or scroll down and you can enter as many as you want. So thanks very much for tuning in, guys, and we will catch you next time.